Dr. Maher is with us.
Good.
Just stand by just in case you can catch up. So Dr. Maher, you will be speaking at the background. I will not gonna put you on the screen. No worries. We will proceed exactly what you want. So whenever you welcome the speaker, I will play their presentation on the stage, correct?
I will start by welcoming for the first session. I will just mention all the speakers together, not one by one.
Okay, sir. Elias, so in that case that Dr. Maher will do like that, so are we gonna proceed with our plan, correct?
Yeah, okay. Next session, just you put the slide, the screen. I will mention. Okay, I will mention the name only.
Okay, Kalas. Okay. Dr. Maher, the timer will be like in 1 minute. We will be live, so I will put your photo on the beginning.
I will be the first one to speak. Is that right?
Correct, sir.
Okay. So what I will do, I will welcome everybody and saying we have 2 sessions. First session will have 6 speakers, starting with His Excellency the Governor, and I will mention the names. Then you will play one by one. I will not interfere between them. Is that correct?
Correct, sir.
Okay. Good.
Dr. Faisal Alyani sent me updated bio, so
I'll just mention his name. I will not mention any bios about anybody.
Okay, sir. Okay, sir, you can start, sir.
Okay.
You're live.
بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. نشكر المؤسسة العامة لتحلية المياه، نشكر معالي المحافظ على استضافة هذه الندوة. الندوة هذه تحتوي على فقرتين رئيسيتين. إذا تسمحوا لي أتكلم باللغة الإنجليزية لأن هناك بعض المتحدثين لا ينطقون اللغة العربية. First of all, we would like to thank His Excellency the Governor for SWCC and also SWCC for organizing such event, and also the Ministry of Energy to contribute to this event. This event is crucial for Saudi Arabia because, as you all know, that we desalinate millions of cubic meters per day, which translates into billions of liters per day. And it requires a lot of energy. It is an energy intensive, either through thermal processes or reverse osmosis. And from SWCC strategy is that to make this as efficient as possible and also to reduce the consumption of fuel or electricity in this process. Without further ado, I would like to introduce the first session that we have about 6 speakers, starting with His Excellency, the Governor of SWCC. His Excellency will start the speak. His Excellency Al-Muhandis Engineer Abdullah Al-Abdul Karim. Then we will have also a short speech from Engineer Nasser Al-Qahtani from the Ministry of Energy, and also Engineer Faisal Yamni from Ministry of Energy, as he's the leader of the Renewable Energy Project. Then we will have from Thomas Altman, 6 speakers, Carlos Costin, he's the IDA president of the International Desalination Association. And last speaker for the first session is from Professor Rojik Novak. Then after that, we'll have a short break. Then we will go to the technical speech as we move forward. So if you allow us, we'll start with the session and we'll play the speech as they go. Then we will move to the second session after that. So please bear with us, and I'm sure that you will have a lot of information out of this speech, and we can start right now. Thank you.
Yes.
Yeah, first speaker. Ladies and gentlemen, good evening. Assalamu alaikum wa rahmatullahi wa barakatuh. Let's start with the first speaker, His Excellency Engineer Abdullah Al-Abdul Karim, the Governor of SWCC. Before he begins, allow me to introduce him. He was appointed as the Governor of SWCC in May 2020. He served as the Deputy Governor for Planning and Development. Throughout his 20 years of experience, Engineer Abdullah occupied multiple senior positions in the Southern Water Conversion Corporation. His Excellency has a lot of experience. You can see it through the information box. All right, Engineer Abdullah, the stage is yours.
مساء الخير للجميع، ويطيب لي أن أكون بينكم اليوم لنعرف بعض أهم الأرقام في قطاع المياه على مستوى العالم، ونؤكد على مسؤوليتنا جميعا في هذا المجال الهام، خاصة مع كثرة التقارير عن شح المياه وفرص وجود عجز في بلاد المياه على مستوى العالم أجمع. اليوم ونحن نجتمع في هذا المؤتمر بعد أن نشكر القائمين عليه، يطيبني أن أقول فرصنا واعدة جدا في إيجاد مصادر المياه لا من الطاقات النظيفة. لدينا فرص واعدة جدا في خفض تكلفة إنتاج المتر المكعب من المياه المحلاة. أيضا لدينا فرص واعدة في الحفاظ على البيئة من الأثر الذي قد ينتج عن الطاقة عن المحطات الحرارية أو عن الرجيع الملحي. كل هذه الفرص يقودها التطوير التقني والاعتماد على تنمية المعارف والتغذية الراجعة. اليوم نحن نتكلم في المؤسسة العامة لتكلم المياه المالحة سويك عن 47 سنة من الخبرة. أصبح لدينا كم معرفي كبير، واستطعنا خلال السنتين الماضية أن نسخر هذا الكم المعرفي في إيجاد حلول أفضل في مجال خفض تكاليف تحلية المياه. أيضا استطعنا خلال هذه الفترة من العمل على استبدال محطات الحرارية، وهي قد الإنشاء حاليا تستبدل بمحطات تناظر عكسي حفاظا على البيئة، الأمر الذي سيجعل هناك حفاظ على البيئة بما يعادل 34 مليون طن من الكربون انبعاثات سنوية في السنة. أيضا لدينا وصلنا إلى مرحلة متقدمة في التصميم الهندسي الصفر رجع ملحي، هي بين يدي المستثمرين، وسنعمل على تفعيلها واستثمارها قريبا من منظومات إنتاجنا. فيها فرص واعدة للمعادن والأملاح. نعمل على خفض التكلفة من خلال خفض استهلاك الطاقة الكهربائية، وكما يعلم الجميع حصلنا مؤخرا على رقم جينيس في منظومة إنتاج صغيرة ومتنقلة 5000 و10000 متر مكعب بطاقة استهلاك لا تتجاوز 2.27 كيلووات المتر المكعب. نطمح إلى كسر هذا الرقم قريبا. كل هذا في سبيل إيجاد استدامة مالية من أجل الاستدامة المائية. نعمل مع شركائنا داخل المملكة وخارجها بتعاونات مع مختلف الجامعات الرائدة في المملكة ومختلف القطاعات والجهات الخاصة والعامة خارج المملكة، مع وزارة الطاقة الأمريكية في مجال الصفر رجع ملحي وتقنيات الجيل الرابع الصناعية، الثورة الصناعية الرابعة. أيضا لدينا توجه مع معهد الابحاث القومي الصيني لتطوير تقنيات التحلية. لدينا عمل مع الجامعات العالمية، لدينا عمل مع القطاعات الخاصة العالم. اليوم ونحن نتحدث عن شح المياه في العالم، نحن نتحدث حسب التقارير التي صدرت في المنتدى الاقتصادي العالمي عام 2019 عن المخاطر العالمية، كان شح المياه هو رابع خطر يهدد العالم، ونسبة حدوثه تتجاوز، هو في المرتبة التاسعة من ناحية نسبة الحدوث. أيضا ذكرت اليوم الأمم المتحدة في برامجها وأهدافها في العام 2015 ذكرت أن 70% من مصادر المياه الصالحة للشرب في العالم قد تنضب. وإذا علمنا أن نسبة المياه الصالحة للشرب في العالم من كمية المياه على الكرة الأرضية لا يتجاوز 1-2%، فنحن بالتأكيد يجب أن نسعى لإيجاد حلول مبكرة. الدورة الاقتصادية في العالم كله تتأثر بإمدادات المياه، والعالم من الآن إلى 2030 يحتاج إلى استثمارات تصل إلى 230 مليار دولار من أجل أن يكون هناك زيادة في الناتج العالمي بما يعادل 300 مليار دولار ناتجة عن توفير المياه المحلاة في مختلف المناطق التي تعاني، بما يزيد من فرص النمو الاقتصادي وفرص التنمية البشرية في مختلف أنحاء العالم. لدينا مسؤولية مشتركة مع الجميع، نطمح من خلال هذا اللقاء واللقاءات المتكررة وما سيليها من اجتماعات بينية بيننا وبين شركائنا إلى إيجاد سبل تساهم في خفض التكلفة، رفع الموثوقية، أمن البيئة، الاعتماد على التقنية النظيفة. اليوم المؤسسة المؤسسة العامة لتحلية المياه المالحة سويك تنتج 5.9 مليون متر مكعب في اليوم. قبل نهاية 2023 ستنتج 7.2 مليون متر مكعب من المياه المحلاة في اليوم. كان لديها شبكة كبيرة وتجارب كبيرة في نقل المياه بكميات كبيرة، ستصل إلى 17 مليون متر مكعب ينقل لمسافات تزيد عن 11,000 كيلومتر. وهذه طبعا بطبيعة الحال أصبحت اليوم مناطة بشركة نقل تقنيات المياه، ولكن نتكلم عن وجود خبرات لدى المؤسسة تستطيع المملكة العربية السعودية التشارك فيها عالميا وإيجاد حلول لمختلف المشاكل التي قد نكون سبقنا في مواجهتها، ولكن المملكة بدورها تسعى دائما لتكون لها دور جانب إنساني في أدوارها المختلفة. وأعتقد أن اليوم الفرصة متاحة، نرحب بالشراكات ونرحب بالتعامل. لدينا معهد الابحاث يتطلع إلى الشراكات مع مختلف الجهات، ولدينا أكاديمية تدريب جميع من يعمل اليوم في المؤسسة خريج هذه الأكاديمية لديه القدرة على التدريب. لدينا طاقات شابة تعمل حثيثا لخفض تكلفة إنتاج المتر المكعب، والحمد لله نجحنا من العام 2019 إلى العام 2021 في خفض التكاليف الرأسمالية لبناء المحطات بما يعادل 30%. نجحنا في خفض التكاليف التشغيلية باستخدام التقنيات الحديثة والتي نتبناها كثيرا كالذكاء الاصطناعي وتعلم الآلة والإنترنت اوف ثينجز في منظومات النقل مثلا أو منظومات الإنتاج. نعمل على خفض التكاليف التشغيلية وسنصل بإذن الله بمشاركة الجميع. ونحن نقول قطاع المياه يحتاج حس المسؤولية على مختلف أنحاء العالم. في المملكة العربية السعودية لدينا حكومة تسعى دائما لرفاهية قاطني المملكة العربية السعودية، ولدينا خطة واضحة للعرض والطلب نعمل وفقها. سيكون الوضع دائما في حالة تقدم، ووجود تعاون دولي سيزيد من سرعة هذا التقدم وسيزيد من فرص استفادة العالم. أنا أشكركم جميعا مجددا على حسن الاستماع، وكان لي شرف الحضور وإلقاء هذه الكلمة، وأتطلع إلى لقائكم فردا فردا متى ما كان هناك فرص عمل مشتركة، وبإذن الله يكون قطاع المياه آمن ونستطيع تدارك العديد من المخاطر التي تهدد التنمية البشرية في العالم. شكرا للجميع.
Thank you, His Excellency Engineer Abdullah, and it's now my pleasure to introduce our second speaker, Engineer Nasser Al-Qahtani. Engineer Nasser Al-Qahtani is the Deputy Minister for Electricity Affairs at Ministry of Energy, where he is overseeing the development and implementation of electricity sectors, policies, and strategies. Before joining Ministry of Energy, Engineer Nasser held many executive positions in private and public sectors. Engineer Nasser has more than 25 years of experience in energy industry. Ladies and gentlemen, please join me in welcoming Engineer Nasser Al-Qahtani.
Assalamu alaikum wa rahmatullah. Good evening, my colleagues. I would like to thank our friends in SWCC and His Excellency the Governor for giving us this opportunity to participate in such important session. I think the world now is noticing and facing a lot of changes almost everywhere. And throughout my career, I have seen a lot of development happening in the generation of electricity, as well as water desalination. And most of you recall that the technology was at that time is thermal desalination plant, and you have seen RO is getting more momentum, and now it become the dominant technology all over the world. There are many changes happening in the past, but I have seen one common thing throughout my career. There is always a relationship between water and energy. Both of them are interdependent. And this will pose a very important challenge to policymakers. How are we going to plan? How are we going to work together so that we can ensure that we're going to implement cost-effective and reliable and efficient systems in both water and energy. Thanks God, here in Saudi Arabia, we have very good collaboration and cooperation with our friends in water sectors. And during the last 2 years, we have been working together to define the water requirements, as water now getting more to be a demand centers, and we have getting all the requirements from their side. Also, we have been working together in the supply side, where we look at different plants that could be retired and we can improve the efficiency. And so it started from looking to the power mix. What's going to be the power mix for the future here in Saudi Arabia? And if you talk about our current power mix, you are talking about almost it's 100% based in hydrocarbons. I know there's a SCACA project that just have been generating power from solar recently. But if you look really to the dominant, it's like 50% of our generation fleet is based in liquid, and there's another 50% is based in gas. And the question, how is our future power mix will look like? And here in Saudi Arabia, we look at from efficiency perspective, environmental. We also look at how it's going to impact our economy in a way or another. And we envision that our power mix in the future will be completely changing. As we anticipate that 45 to 50% of our generation mix in the future will be coming from renewable resources. The other 45 to 50% will come from gas-based, high efficient generation facilities. And we will have 5 to 10% maximum that will be based in liquid, and it's going to be in very specific locations, very specific applications, where it's going to be very difficult to transfer and transport gas to these locations. And there's going to be another requirement when it's come from electricity perspective, electricity stability perspective. So in the future, we are seeing a change. We see more renewable coming. That resulted in very many benefits to Saudi Arabia in reality. And we, as a result of implementing these programs, we will phase out around 1 million of oil equivalent, 1 million barrel of oil equivalents from different types of liquid fuels by 2030. That will result in many benefits from environmental perspectives. It will help us to reduce the electricity cost. It will fill around 1 million of oil equivalent barrel for export, and also for another industries like petrochemicals. Oil to chemical programs is very important. One of the 2030 vision program that we need to execute and implement. So in a nutshell, we see there is an interdependence between water and power. We see it's very crucial that we work together when it's come to new plants that will be built, and also to the existing facilities, which one of them that we retire, so that we can improve the overall efficiency to the systems. And I have to be frank here and say that our friends in SWCC have been doing an excellent job in that regard, where they have retired a lot of plants that are burning liquid, and now they are moving more to RO. Moving to RO, moving to renewable energy resources will pose many challenges, and one of them is intermittency. And also there is a challenge when it's come to storage, where you need to store water or electricity. That's a very important point to look at it. I think I stop at this level. My colleague Faisal Al-Yumni will take it to a different level, where he will talk about the renewable energy program in Saudi Arabia. And I'm really enthusiastic to listen to the sessions and learn and understand many of the challenges and the solutions that you are proposing to solve problems, and how could we address the interdependence or the delicate interdependence between water and energy. Wish you the best. Assalamu alaikum wa rahmatullah.
Thank you, Engineer Nasser. And now with Mr. Faisal Al-Yumni, the third speaker in this session. Mr. Faisal Al-Yumni brings with him over 18 years experience in the energy industry. His professional experience spans renewable energy, power systems, and much of oil and gas value chain. Faisal Al-Yumni was the CEO of the GCC Assets Investment and Development Company, from which he joins Ministry of Energy as head of renewable energy. He worked previously as head of Power Systems Support and Investment Division, as well as co-led refinery petrochemical transaction with international operation at Saudi Aramco. And Engineer Faisal, the stage is yours.
Good evening, everyone. Thank you so much for having me here tonight. It's a pleasure to be part of this important event, and I'm very delighted to present Renewable Energy Program and the success stories and accomplishments so far. As you may know, in early 2017, the Renewable Energy Program was launched to meet the renewable energy goals in line with the Vision 2030. The program targets to contribute to the Kingdom's optimal power sector energy mix by accelerating renewable energy development of up to 50% of national energy mix by 2030. Ladies and gentlemen, our principles are fairness and transparency, the competitiveness, timelessness, risk mitigation, diversification, and the value that we bring all together to the Kingdom. All renewable energy power plants are built through independent power producers, where local and international developers are invited and encouraged to participate. So far, we were able to put in the market a total of 13 utility-scale projects of solar and wind energy sources, where the Kingdom achieved the lowest LCOE for solar energy worldwide through competitive bids. The high competitiveness that we have established so far in Saudi Arabia is due to several reasons. To begin with, the geographical location of the Kingdom is a great advantage. The availability of lands makes it attractive for developers, and we clearly have a very high irradiation, which can be translated into a high energy production for the solar plants. Moreover, the Ministry of Energy, along with other stakeholders, has been working to facilitate the trading and commercial aspect to help investors and developers in establishing and developing utility-scale projects here in the Kingdom. Ladies and gentlemen, if you allow me to go over the major achievements here, we're talking about several rounds that have been tendered in the market or under construction as well. For round one, we have a total 700 megawatts of solar and wind projects, 300 of which for Sakaka project, which is under operation now. Domatel Jandal with a total of 400 megawatt wind is under construction, and we are expecting the completion soon. For the round two, we released the bids in the market back in 2019 quarter three with a total of 1,470 megawatt with a total of 6 PV projects. Jeddah Rabigh projects, each of them is 300 megawatt. Al-Shaiba projects with a total of 600 megawatt capacities. The remaining projects are Qurayat, Medina, and Rafha with a total of 270 megawatt of solar projects. In addition, we have Sudair PV project with a total of 1,500 megawatts, which is already completed and will be under construction soon. As far for round 3, we have released the bids for the 1,200 megawatt for 4 PV projects, and these projects are in the bidding stage, namely Al-Ras project with 700 megawatt, Sa'id project with 300 megawatt, Wadi Duwasir 120 megawatt, and Layla project with 80 megawatt for solar projects. And this hopefully will be finalizing its bidding and the commercialization and finalization of the projects before end of the year. Thanks to the great development of water desalination technologies that combined with renewable energy, we are certain to see a lot of projects in near future which combine solar energy and desalination plants to produce more water, especially with the demand profile for clean water in the Kingdom. By this, I conclude my part, and thank you very much for your good listening.
Thank you, Engineer Faisal. And now let's move to the next speaker, Engineer Thomas Altman. Thomas Altman, Vice President of Water and Innovation at Aqua Power. He gained his experience by working for more than 25 years for top-ranking engineering and construction companies. Before joining Aqua Power, he held an EVP positions at ILF Consulting with global responsibility for energy and desalination business, and was MD for ILF Business Consultant. Engineer Thomas, the stage is yours.
Excellencies, honorable guests, distinguished audience, ladies and gentlemen, good evening. It is a great honor and privilege to address you today at this SWCC webinar on renewable energy for desalination. According to the World Economic Forum, water crisis ranked among the most serious risks facing society, and the top 5 risks in terms of likelihood are all related to water. The problem of grossly inadequate water supplies for a world growing thirstier by the day is one of the leading challenges facing the generation and is gushing out of control. Water scarcity is a significant challenge and is intrinsically linked with the demand growth for energy and has made desalination a fast-growing technology, a reliable solution to produce fresh water. However, desalination as a process that relies on just a few strands of technology was first developed by the 50s and 60s and has been passionately nurtured over time by none other than the Kingdom of Saudi Arabia. Today, desalination continues to grapple with 3 challenges: cost and thus affordability, energy intensity, and environmental impact. Currently, desalination is largely limited to more affluent countries, especially those with ample fossil fuels and access to seawater, due to its relatively high energy and environmental cost. To make it more affordable and accessible, researchers around the world are studying how to improve desalination processes, devising more effective and durable membranes, for example, to produce more water per unit of energy. A significant cost of desalination is due to the energy consumed by this process. Despite the significant reduction in energy intensity over the last few decades, even today, a significant portion of the cost of desalinated water goes towards paying for the energy. Given that almost all this energy today is being provided by fossil fuel sources, desalination is contributing to the emission of carbon into the atmosphere, which is contributing to climate change, which in turn is contributing to the very water crisis we are relying on desalination to solve, thus placing desalination at the center of a vicious accelerating cycle. The prospect of generating cost-competitive renewable energy precisely at the location where we need desalinated water could help to break this cycle. Renewable energies are rapidly increasing their share in the global mix and can provide access to cost-effective, secure, and environmentally sustainable supply of energy that can be used for desalination. What hinders the wide adoption of solar and wind, the 2 most abundant renewable resources in the Arabian Peninsula, is the intermittence of energy supply, which decreases the utilization rate of desalination plants to a limit which is not financially sustainable for municipal water supply. Hence, deployment of low-cost energy storage technologies is inevitable. They will act as key enablers for the reliable supply of renewable energy for baseload desalination plants. In parallel, we need to keep working to reduce energy intensity of this process. What I want to highlight is that even if renewable energy cost continues to fall, the reduction alone will not be able to contribute towards reducing the cost of desalination. Renewable water needs to be seen as an asset and pillar in the green economy, just like renewable energy. The water-energy nexus and the integration of renewable energy sources into desalination is a crucial step towards a sustainable future. Living in the Middle East that is substantially dependent on desalination of fresh water, I'm proud to say that ACWA Power, a leading developer, owner and operator of power generation and desalination plants worldwide, of which I am privileged to be part of, has made a meaningful contribution to mitigate these challenges associated with making desalination viable and affordable, and to provide a long-term sustainable value to resolve the critical water scarcity situation facing the world. At ACWA Power, we relentlessly pursue our mission to reliably provide electricity and desalinated water at the lowest possible cost in the countries we operate in. We work actively alongside well-established state-owned companies like SWCC, who have been pioneers in developing and nurturing this technology for decades. As we go forward, recognizing the scale of the challenge we have in front of us, the one thing that should matter the most is that adequate water supply is made available to spur economic growth, to support human life, and to foster social harmony. It is essential that this water supply is safe, reliable, sustainable, and accessible at the lowest possible cost. Excellencies, honorable guests, distinguished audience. Ladies and gentlemen, thank you for your attention. Wish you a pleasant evening.
Thank you, Mr. Altman. Ladies and gentlemen, our fifth speaker in this session, Mr. Carlos Cousin. Mr. Carlos is currently the president of International Desalination Association, IDA, and Chief Executive Officer of Al-Amr Water Solutions, part of Abdulatif Jamil Energy, a division of Abdulatif Jamil. Mr. Cousin has 25 years of experience in the water industry, including the development of desalination, wastewater, and reuse projects around the world for both municipal and industrial sector. Mr. Carlos, the stage is yours.
Good morning, everyone. First of all, thank you very much for the opportunity to share this important event organized by SWIC, and thank you for the special invitation from our partnership, the governor, which is supporting IDA from many years. And my first message is just want to emphasize the importance to cover this new path to couple desalination and alternative renewable sources, okay? Because desalination has growth one more year in awarding contracts, contracting capacity, as well as installing capacity. And especially important to mention the scale up of the sizes are being built, which demonstrate the technology has reached a very high degree of maturation, as well as the very good performance and technological efficiency. But not only the sizes is something that is remarkable. How the technology has been adapted to new contractual models from EPC to BOO, BOT, or any other alternative financial solutions. How the technology is being expanded to new geographies and for new uses in the industry, from the food and bev, oil and gas, or mining, or even its use in agricultural for irrigation purposes. All these advances has proven the water produced by desalination is always affordable and competitive. Therefore, the next step, which all the sector is in mind, is how to go forward to reduce as much as possible the CO2 emissions, and therefore to have desalination more in the new era with free emissions, okay? This is the topic of seminars, and I hope that all the attendees can enjoy the professionalism of this webinar. Okay, thank you very much.
Thank you, Mr. Carlos. And last speaker in this session, Professor Rojik Novak. Professor Rojik Novak is currently director in AGH University of Science and Technology in Poland. He graduated with honor in 1979 at the Faculty of Thermal Engineering of the Mariupol Technical University in Ukraine. He received PhD and DSc degree in technical science at the Gdańsk University in 1983 and 1991. He became an associate professor in 1997 and full professor in 1998. From 2014, he is vice dean for science at the faculty and currently serves as a PO director of the Center of Energy at AGH University of Science and Technology. Professor Novak, the stage is yours.
Good afternoon to all of you. It is my pleasure to be with you. My name is Wojciech Novak. I am from AGH University of Science and Technology in Poland, from the beautiful city Kraków, which is the largest academic center in Poland. Many students, more than 200,000 students, with one of the oldest and most eminent university in Poland. Personally, I am director of AGS Center of Energy, which is the largest investment in our university. By the way, our university is the largest technical university in Poland. In my center, I have more than 40 very well equipped laboratories. Of course, our area is mainly energy, conventional energy, but also renewable energy, industrial power engineering, electrical grids, and other. Of course, one of the main topic also is the desalination technologies, mainly in the area of energy and water, and mainly to use alternative source of energy for solar-driven desalination processes. One of these solar desalination processes is combination of photovoltaic technology with reverse osmosis technology. And what is our idea and our concept, which we are developed together with our partners in Saudi Arabia, is cogeneration when we can use a low-grade waste heat, let's say with a temperature 60, 85 degree. This process is absorption cycle, and in addition, we can do also cooling. Here you can see our technology developed jointly by company NET from Poland, and also together with our partners from Saudi Arabia, King Abdulaziz City for Science and Technology, where you are using, as you can see here, solar to cool and also to desalinate water. When you see this table, you can see comparison for various methods of seawater desalination. Our process is absorption desalination, which consumes much smaller energy compared to other processes, and also making high energy costs of water, as you can see here. And finally, you can see here our equipment, which is a demonstration plant located in Kraków, in my center. And some of you had a chance also to visit us to see this demonstration plant for desalination using waste heat and using also solar heat. More detail will be presented here during your webinar by my college. If you have any question also and interest in working with us, you can contact me directly. Here you can see my address, and also here you can see my email. I wish you all the best, and thank you very much.
Well, I would like to thank all the speakers, and I should mention that there is a 10-minute break. Then we will start the second session, and the second session will focus on how to combine the technology of renewable. I should mention that it's renewable, not just only solar, and also the desalination technique. So if you allow us, we will come back at 7:50 to start the technical session with a total of 4 speakers. So we'll see you in 10 minutes, please.
Okay, you can call, I think, call him, Lester.
هذه هي منظومات الإنتاج المتنقلة في المؤسسة العامة لتحلية المياه، واحدة من الإنجازات النوعية التي صنعت في السعودية بكوادر وطنية مؤهلة، صممت، نفذت ووردت. إنها إحدى أهم التقنيات المتطورة في العالم التي ابتكرتها التحلية ووثقتها موسوعة جينيس برقم قياسي عالمي غير مسبوق، الأقل استهلاكاً للطاقة في العالم بمعدل 2.27 كيلو وات كل ساعة لكل متر مكعب من المياه المحلاة فقط. فلسفة تصميمية مبتكرة خفضت الطاقة إلى مستويات غير مسبوقة. نظام متنقل لمأخذ مياه البحر بأحدث تقنيات استرداد الطاقة ERD، مزود بمضخات عالية الكفاءة. رقم قياسي جديد،
وهذه الأرقام القياسية التي تسجل اليوم بعد آخر هي شاهد على تميز هذه المنشأة.
شكرا عليكم على هذه الكلمات المحفزة.
رؤية قيادة رشيدة وجهود كفاءات مؤهلة آمنت بقدراتها وحققت أهدافها.
Camera? I couldn't see your camera, sir. Dr. Faisal? Yeah, please.
Yes. That
you, Your Excellencies, and participant speakers. We heard in the first session about the main policies and intentions of the world in general, and specifically for Saudi Arabia, for the power sector, and as mentioned by Engineer Nasser about the energy mix, and also as mentioned by Faisal Al-Yemni that about the renewable energy project for power generation. Then we heard from His Excellency, the Governor, the plans for SWCC to reach actually about 7 million cubic meters per day of desalinated water. That will place the kingdom to be maybe the largest desalinator with about 20 to 25% of capacity. The main objectives of today's webinar actually is really looking at the very well developed desalination technologies, albeit being the reverse osmosis. As mentioned, it is probably more environmental friendly, and thermal processes, even though it takes a lot of power per cubic meters, maybe 3-4 times reverse osmosis, but yet it's been widely used in Saudi Arabia and the Gulf region for many reasons. One of them is the lower operation maintenance and also the relatively inexpensive fuel price in the past. Now things will change in the future, will be liberated, the fuel prices. Hence, having all this technology development in renewable energy and also the technology development in desalination, the aim of this webinar is really to combine these technologies. I've seen some of the presentations where it would look at the technologies from a perspective of hybrid technologies between renewable and desalination from the grid directly or off of the grid. And there are some effort actually to design the renewable energy specifically for desalination. I would like to bring example for DC high pressure pumps, where you can feed the PV or photovoltaic field directly to the reverse osmosis power without converting it to alternating current, just directly to DC, and other technologies as well. And I would mention that there is an effort or efforts to bring the mechanical power of wind directly to reverse osmosis without electricity generation. That's for photovoltaic, but also for thermal technologies, we need to look at utilizing solar thermal energy in providing the proper energy, the proper temperature and other fluid requirements in order to desalinate water, seawater by evaporation, by other techniques using direct thermal energy of solar. We have in this session, we have a total of 4 speeches. First one, I will be introducing each speech as we move forward. First one from Engineer Faisal Al-Umar, who is at KA Care, and he joined KA Care in 2014. Faisal is currently leading the Renewable Energy Business and Application Developments Division. And before actually joining KA Care, Faisal worked with SABIC for over 12 years, increasingly responsible in engineering, project management, and technology and innovation. Faisal, actually, I worked with him. I had the pleasure to work with him for many years, and I would like to give him the floor to give us this presentation to bring all the technologies for renewable energy technologies for this water desalination and bringing it in a perspective that I think it will be an interesting perspective. Faisal, please go ahead.
Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Thank you, Dr. Maher, and thanks to Saudi Water Conversion Corporation for organizing such important program to address the water opportunity for renewable desalination. Today, I will present on renewable energy desalination opportunities for KSA. The agenda will cover the following items. First, renewable energy global trends and KSA recent development, potential renewable desalination opportunities, and KCare recent effort in renewable desalination. The energy transition is underway. to change the global power generation mix, favoring electricity powered by renewables. Electricity shares has been growing and will double from today level by 2050. Renewable is taking the major chunk of the generation mix by 69%, and mainly solar and wind would contribute to 56% of the electricity globally in 2050. The important takeaway of this trend is that renewable energy will be the dominating energy source of electricity generation in the future, and sustainability requires us to change in a way we produce, manage, and use energy. There are 6 major trends driving change in the global energy sector. Start with the evolution of the technologies and digital transformation. Many different technologies are in the development stage, and which is expected to change our style of living. Seeking to reduce the carbon emission and climate change, there is increasing international interest in climate change as it is a real threat. The current pandemic has brought forward countries and international organization alignment, pushing to reduce CO2 and greenhouse gas emissions. Increasing the competitiveness of renewable energy sector, the cost of solar and wind is significantly reducing, increasing the competitiveness compared to fossil fuel sources. There is also diversity of energy sources and increasing sector interdependency and electrification, which is a major trend like the global spread in the use of electric vehicle and the electrical mobility in general within the transportation sector, that effect on the electricity sector. Last but not least is the growing geopolitical role in the energy security. And we see also renewable is getting recently also as part of the geopolitical energy security. The surprise COVID-19 pandemic has also affected many trends, but in positive note, the share of renewable energy is expected to outpace forecast post-COVID. The shift into renewable is also due to continuing unsustainable cost reduction through technology improvement and economies of scale, and also efficiency of the producing and technology becoming more competitive than other fuels. Today, renewables are cheaper than fossil for electricity generation in many countries. Further decline are still expected. It's dominated by wind and solar PV leading this domination. It's evident that renewable energy becoming the cheaper, but it has its own challenges to be addressed, like intermittency and grid management. Enabling technologies such as batteries are experiencing rapid reduction in cost, which might further enable renewable adoptions. Storage batteries get cheaper over time via synergies with growing battery demand for electric vehicle. Batteries pairing with PV in sunny regions like the Kingdom will be a viable solution to meet the base load demand after the sunset. The battery storage capex also declining, giving the economics as a favoring perspective. The Kingdom is not as an exception. The energy sector in the Kingdom is witnessing an important and fundamental transformation, including the commitment to develop a strong renewable energy sector. The Kingdom has clearly started a renewable journey as part of the Saudi vision, targeting 58 gigawatt by 2030, and has achieved a very promising levelized cost of electricity, where the Faisaliya project has a record levelized cost of electricity with 1.04 US dollar cents. Then we move forward for the potential renewable desalination opportunities. KSA is worldwide market leader in terms of desalination capacity and production. The Middle East and MENA is contributing for 47.5% out of this market in 2019. KSA has currently a desalination capacity of 7.7 million meter cube per day. The demand is growing, and the desalination to fill the supply gap is also expected to increase. A new desalination plant expected to supply 10 million cubic meter per day in 2025 and 8.4 in 2030. RO technology comprises half of the total desalination capacity, mostly for commercial or industrial use in the small unit. The water scarcity associated with a high fuel consumption on desalination create another important application for renewable. Renewable and desalination can be coupled in many different ways through electrical and thermal coupling. The energy consumption is one of the deciding factor for best coupling scenario. The PVRO currently are the most wide deployed technology for renewable energy desalination. The adoption of renewable for desalination in KSA should be further deep dive in order to find the best solution for KSA ecosystem. A new pioneering technology is also underway in projects like NEOM Solar Dome. So we move forward to the exploring the most prominent technological combination between renewable and desalination. PV desalination system, which usually depend on reverse osmosis units, can also be buffered by a grid connection or battery storage. The main advantage for PVRO system is water cost advantage over fossil fuel component commercially available. The viability depend on plant capacity, distance to grid, and feed connection. Many pilot and commercial, and it's considered to be a mature technologies. We would also highlight that the new desalination project announcement of Yumbo 4 and Jewel 3 is an evidence that PVRO is taking momentum as a viable economical option. The disadvantage for it's considered to be for a standalone solution, no power grid connection, energy storage required for energy fluctuation. Also, it's the noticeable decrease in the prices of solar PV module, and also continue a decrease in the levelized cost of water of RO market is a sign that both the photovoltaic and the reverse osmosis market are showing a promising and attractive economics. Just give a high-level indication that 56% decrease in the levelized cost of energy would contribute to the reduction of the levelized cost of water by 19%. This is just an indicative figure to show how significant the impact of the energy on water cost. Another source of a viable combination is wind energy, which is mature technology proven to be economically feasible when combined with desalination system. The advantage is the high pressure source allow for mechanical coupling and robust flywheel energy storage, seen as one of the most promising combination, mature and proven. Decreasing wind turbine cost and RO component cost would also promote the adoption of renewable desalination. The main disadvantage is fairly restricted to areas with a high wind speed and high fuel prices. The price variation and interruptions compromise component lifetime. Wind energy has been directly converted to mechanical energy for centuries, and it is possible to couple it mechanically to a desalination system like RO, but this is something that would further require some research development. Another option is the concentrated solar power. When combined with the desalination system, heat can be ejected from low pressure steam turbine and feed into the brine water heater instead of expanding in further low pressure. The main advantage is also CSP now is getting mature. Technology, the cogeneration with the thermal and also additional to electricity. A cogeneration is a viable option, promising for electricity and water provision. And it's economical in cases with CSP RO. The main disadvantage is the fairly suitable economics is yet to be improved and coupling challenges mainly with RO. So here is we give a summary given the level of intermittency and low maturity in some renewable energy solution and the planned investment in the new desalination plant. Several techno-economical studies should be performed to quantify the benefit against fossil fuel desalination plant. And we summarize the challenges, which is intermittency of the RE technology and integrating with renewable energy sources directly with desalination unit runs the risk of providing intermittent and fluctuation power to the desalination unit. Some technologies not yet reach a high technology maturity or readiness level or cost effectiveness. Lack of information and studies regarding renewable desalination opportunities and the market in the kingdom, given the rapid changes that are happening in the renewable energy and storage technology. There is a potential RE desalination solution where we need to manage the trade-off on cost and benefit of the usage of energy storage, location for the renewable energy resources, solar and wind, or even a combination of hybrid solution, and the desalination technology that would need to maximize electrical output and definitely for optimize the levelized cost of water. Second, enabling solution would require performing a full techno-economic assessment must be performed for different combination of renewable energy and desalination technologies. Solar PV, wind with RO, and different energy storage technologies versus the CSP with molten salt and MED technologies. K-Care is currently working to address these opportunities and challenge, and we here would like to share with you the recent effort in renewable desalination. K-Care has developed plans to evaluate the opportunities and challenge in the RE desalination. One, the initiative, economic estimation of the cost of desalinated water using fossil fuel, renewable energy, and nuclear energy. It's a comparative economic analysis of a cost of desalinated water in Saudi Arabia using versus various energy sources and technologies. It's a collaborative project between K-Care and King Saudi University. Its analysis models were used to evaluate the cost of desalinated by MED, MSF, and RO using renewable energy sources. 14 coupling scenarios on renewable energy desalination have been considered, and 6 scenarios where the least cost of levelized cost of water, with BVRO being the cheapest. K-Care also, with another initiative, aimed to conduct a techno-economic feasibility study for case of BVRO, considering a multiple scenario specifically for the photovoltaic reverse osmosis technology coupling, considering different zone in the kingdom, and also having a simulation to visualize and analyze the energy flows for each scenario. In a third initiative, K-Care is also collaborating with Korean Atomic Energy Research Institute and KAIST to study and develop a conceptual development for nuclear desalination plant to enhance its economical efficiency and safety by simplifying and optimizing a nuclear reactor dedicated on desalination. K-Care is currently funding a relevant renewable energy related initiative under 4 programs across 9 themes. And one of the major themes are renewable energy in water management, currently in round 4 in commercial demos and round 1 on the other 3 programs, further further rounds expected in the second quarter in 2021. Before ending my presentation, I would like to highlight that the world is running out of drinking water, and to combat water scarcity in the 21st century, the world needs to bring effort together for viable solution. That is our mission. Thank you very much.
Well, thank you, Faisal. Thank you for bringing all these technologies together. I think each of these combinations will require a dedicated research programs and development of the technologies, and also proof of the concept, then commercial development, all of that. So it is a long way to go to the actual market, but we have to do it. I think that Saudi Arabia should be the leader in developing these technologies, because we have both incentives. We need water, and also we have one of the best solar installation in the world. So I think we could be the leader for the world in doing these technologies. It is a pleasure to introduce the second speaker, Dr. Faisal Al-Marzouqi. It's really a pleasure to have him in our webinar. Dr. Faisal, he has a PhD from what is called interdisciplinary engineering as a joint program from Masdar Institute and MIT.
Bismillah ar-Rahman ar-Rahim.
2005.
Thank you for
2015. I'd like to introduce Dr. Faisal. This is the first time I meet you, so if pleasure to have you here. And also he's working as assistant professor at Al Khalifa University right now. So Dr. Faisal, it's your floor. Go ahead.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Thank you for the host here to host me in this session. I am from Khalifa University Masdar Institute, and I'll be talking to you today about solar desalination. To introduce the subject, first of all, we will be talking about solar desalination in particular, but to understand the context of solar desalination, we need to come out and look at the current status of desalination across the globe as a technology in the form of research and industry, various aspects of this sector in terms of desalination. So why are we looking at renewable energy desalination? So solar desalination is a type of a renewable energy desalination technology, and to understand the reasons behind this, we need to look at the energy requirements. So basically, desalination is a sector which is in high demand of. The state of the art today in desalination is seawater reverse osmosis, SWRO. And we have seen a lot of development in SWRO over the past 5 decades. It has been the state of the art technology for a very long time, and it is still to date. In terms of the energy requirements, we have seen a drastic development where the energy requirement has fallen by a factor of 5 over the past 5 decades. This is a huge, but is it enough? To answer that next question, whether it is enough or not, let's see how much actually this technology utilizes in energy yearly across the globe. Seawater reverse osmosis utilizes approximately 100 tons, watt-hours per year across the globe. And that translates to 100 megatons per year of CO2 emissions, contributing to the global warming and climate change, as you obviously know. And that's the reason behind what we have in terms of the move towards renewable energy desalination. So the efforts have been in reducing this energy consumption in desalination, not looking at the source of energy, but looking at reducing the requirements of the technology. And to date, the record is still in the Kingdom of Saudi Arabia. Actually, it is with our host today. they set the world record in terms of the minimum energy consumption, and that is currently at 2.271 kilowatt hour per meter cubed. That is the latest figure I have seen in literature, and it dates to this year itself. But to put things in perspective, if you look at the thermodynamics and the laws of physics, desalination has obviously a thermodynamic limit, which you cannot go below. And that is approximately between the values of 1 to 2, depending on the salinity of your seawater. So you could see clearly that we are very close to the thermodynamic, which we cannot go below. And that takes us to the fact that now we need to look into the sources of energy. And instead of trying to minimize the energy consumption, look at the source and try to make it more green. We sometimes call it green energy, we sometimes call it renewable energy, we sometimes call it decarbonization of the technology. And basically means reducing the carbon footprint. And once we look at this decarbonization concept of desalination, we look into renewable energy desalination as one of the approaches to decarbonize this sector. Now, moving forward, obviously there are many different types of energy sources for desalination. This figure shows you the current renewable energy sources that have been utilized for desalination. We could see that it is dominated by far by solar. You could see solar almost everywhere. Other types of renewable energy sources is wave, wind, geothermal, and also others include biomass and hydrothermal, and emerging recently, but nevertheless solar is the dominant by far. On the left axis, the y-axis, we could see the maturity of the technology, and we could see clearly that solar CSP MED has been the most mature also solar stills and PV osmosis is also a mature technology. On the x-axis, we see the capacity, and again, solar CSP MED is the highest. One update here is this figure is actually not up to date. So PVRO or PV seawater reverse osmosis actually have moved since this figure to the right, and we actually today have PVRO systems at approximately 1,000 meter cubed per day capacity. So, and later on you will see that PVRO technology when we talk about solar desalination. To understand the renewable energy sources for desalination, we look into this a little bit more complex figure. I don't plan to go through it, but in general, we need to break it down into three different elements. The source, the renewable energy harnessing source. So you could see, for example, here, solar photovoltaic cells as the source through which the technology through which energy is utilized from the renewable energy source. And then in the middle, you see the energy type and converters. So for example, in solar photovoltaics, you get electrical energy, and then whether you need to convert form of energy or keep it the same. And then on the right, the third element is the actual desalination technology. So you could see here pressure-driven reverse osmosis, electrical charge-driven processes such as electrodialysis. And one aspect which is important in this diagram is energy storage. When we talk about renewable energy, energy storage is extremely important because of the nature of this energy source. And here we see fuel cells and rechargeable batteries as one example or two examples of energy storage. When we talk about solar water treatment or solar water desalination in general, there are two different concepts: direct on the right and indirect on the left. What and indirect? So let's start with the simplest, indirect. So indirect means what you do is you take a renewable energy technology such as solar cells, wind turbines, and so on, energy from them, and then connect it to a desalination technology that will desalinate the water for the seawater for you. This is different from a direct concept in which a single device directly utilizes the renewable energy to desalinate seawater. And you will see an example of this towards the end of the slides today. So what is the current status of solar-powered desalination? We see the huge, the most efforts in basically reverse osmosis plants because the fact that they are the state of the art. And this table shows you the current demonstrations online and also planned projects. It dates back to 2012 in systems in the US in terms of the history, but in terms of the capacity, which is always attractive, we see that again, Kingdom of Saudi Arabia is leading, where they have the Al Khafji project, where they plan to have the highest capacity across the globe as a solar-powered reverse osmosis plant. This is not yet commissioned as far as I know, but it is in the plan. Now, when we talk about commercialization, large-scale applications in technologies, cost is an important issue and a factor. We always struggle with cost, especially when we talk about large-scale because of the scarcity of data and the nature of research. Nevertheless, there are some figures that show you indication. So if you start with the typical seawater reverse osmosis levelized cost of water, it's around $1.25 per meter cubed. If we look into solar-powered MD, which is basically membrane distillation, which is one of the technologies that utilize directly solar energy to desalinate water, it is approximately 5 times that of seawater reverse osmosis or more. It goes to 85. Just a note here, seawater is just without the solar power systems. But if we look at hybrid as PV, diesel, RO systems, to the state-of-the-art cost in desalination to 1.6 approximately, which is quite a good achievement. And that shows you the importance of hybrid systems in solar desalination. On another point, membrane distillation is a technology that I just mentioned earlier, and it is emerging in terms of a solar desalination technology when coupled with a solar source. Here we have different for different data points, just general MD, and that ranges from 15 to 18. Air gap membrane distillation, solar powered is 18, and so on. Still, we see that these figures are still on the high end when we compare it to the current state-of-the-art technology. So that's where we stand in terms of cost. But as a researcher in membrane distillation specifically, I can tell you that these numbers mostly stem due to the low recoveries in membrane distillation, which is a fundamental problem in membrane distillation, especially when we talk about solar desalination, solar powered. Okay, so that is basically cost. In the UAE, we have an experience with the solar desalination, and that is through Masdar company. Back in the days when this project was announced back in around 2012, 2013, it was led by Masdar company and different other entities in Abu Dhabi. The idea was, to implement solar desalination in Abu Dhabi in an area called Ghantut that sits between Dubai and Abu Dhabi. And the four pilot plants were announced by 4 various companies in the sector. And later on, 1/5 pilot plant was announced also for this project with these specifications. I'm not going to go into the details. Unfortunately, the project was about after approximately 3 to 5 years. Back then, I was actually a student, so I didn't have a lot of interactions with the teams. But that project is actually discontinued. In terms of research, so what we do in the lab here in Khalifa University Masdar Institute, we do various research in solar water treatment in general. Here I will list for you some examples. We develop photothermal brine desalination technologies, and they are funded by various entities, which I show here, in which we develop basically devices to desalinate brine through a source of solar energy. And another project also within the same context is the photothermal heavy metal removal from wastewater, which is not, but also it is a solar-driven technology for water treatment in the general context. And I'll show you some pictures here of the devices that we developed in the lab. Also, in particular here, I show some data and also further pictures of the research which we do. We basically fabricate membranes that directly absorb the solar radiation and then facilitate a desalination process through which seawater basically is desalinated. In particular, here we use membrane distillation as a concept. And I show you here which we generated in the lab. You could clearly see that the fluxes are typically low when you compare it to conventional membrane distillation. And it is a bottleneck in solar membrane distillation, which researchers are actually trying to overcome. Other approaches to solar desalination is through biomimicking nature. And here we developed basically halophytes that are artificial. We take water from a source and then evaporated based on materials, and then hopefully desalinated in some other process. Lastly, on a large-scale context, we look at we have a project where we look into PVRO and coupling it with MMD, or sourcing it through a solar power. In terms of the future, I see that the future will be mostly in hybrid systems, hybrid renewable energy sources, and hybrid desalination technologies, and also a combination of the two. And lastly, I show here a technology that was developed by Peng Guang's group in KAUST in Saudi Arabia, which actually demonstrates clearly a direct solar desalination device which utilizes both photovoltaics and the concept of membrane distillation. That's and here are some references I used in today's presentation, and that's the end of my talk. Thank you for listening, and I'll be happy to answer questions in later sessions. Thank you.
Thank you, Dr. Faisal. Thank you so much for the interesting presentation and also some of the glimpse of future technologies. I should remind you that we have a dedicated question and answer session, and I believe you can post your answer and we'll take the answers to the desired speaker. Next, we have a presentation from Dr. Carl Sickler, and he's been working with the AGH University of Science and Technology since 2012. Dr. Carl, his specialty and research interest, in increasing efficiency adsorption chillers with desalination function, utilization heat waste from industry process, carbon capture technologies, modeling and optimization of industrial processes. Dr. Carl, it's a pleasure to have you. Please go ahead with your presentation.
Good afternoon. My name is Carl Steckler from AGH University of Science and Technology. The topic of my presentation is use of renewable energy for adsorption chiller with desalination function. Global water demand is projected to increase more than 55% from 4,500 billion cubic meter per year in 2010 to 6,900 cubic meter per year in 2030. Presently, more than 80,000 desalination plants in 150 countries, producing about 58 billion cubic meter per year, and it is projected to increase to 54 billion cubic meter per year by 2030. It is 30% more compared to the 2016. Desalination is the most energy-intensive water treatment process that consumes about 75 terawatts per year. It is about 0.4% of global electricity. Presently, global installed desalination capacities are contributing about 76 million tons carbon dioxide per year, and it is expected to grow to 280 million tons of carbon dioxide per year by 2040. According to the reports of the International Institute of Refrigeration in Paris, the refrigeration sector consumes about 20% of the world electricity production, but for air conditioning equipment in the global electricity demand is about 10% in the 2016. Most of these air conditioners are compressor systems which use electricity. Mostly, electricity is produced from the fossil fuels that have influenced the impact of the total carbon dioxide emission to the atmosphere. One of the humanity's greatest challenges is the growing shortage to the drinking water. According to the projected population growth, it will be even more serious than can affect up to 3.5 billion people by 2025. The commercial destination technology can be divided into two main categories. First is thermal methods, such as multi-stage flash distillated, multi-effect distillation, and adsorption distillation, and membrane methods such as reverse osmosis. In addition, there are different emerging technologies which are still under research and development, including the forward osmosis and membrane distillation and heat rates. The tables show the important parameters of the most common distillation technology. The absorption chiller with distillation function is marked in the red. What is characteristic of this kind of technology is, of course, the operating temperature from the 55 to 85 degrees. Thermal energy is about 39 kilowatt thermal per cubic meters, and electrical energy is about below 1.5 kilowatt per 1 cubic meters. And the CO2 emission is a range from the 1 to the 4 kilogram per cubic meters. This kind of the technology, as such, in the simulation, will compare with a different type, have a very low influence on atmosphere, because the emission of the carbon dioxide is very low, and total electricity consumption is very low. The assertion chiller with desalination function becoming an ecological alternative to compressor cooling system and energy-consuming water desalination unit. They make it possible to operate absorption and desorption cycles using only the low-temperature heat, which can be waste heat or derived from the solar energy. The only limitation of this kind of the technology is large scale, weight, and relatively low efficiency. Absorption chiller devices combined with renewable energy sources are cheap and an ecological source of cooling and desalinated water. The absorption chiller with desalination function have three main components. First, this is the evaporator, bed, and the condenser. In the evaporator, in the lower pressure is about below the 1 kilopascal. The water is evaporated. The steam is flowed directly to the bed, absorption bed. When the absorption process, the steam is absorbed in the acetic acid already on the different absorbents. During the desorption process, we must deliver to the bed the hot water, increasing the temperature with increasing of the pressure inside the bed, and we release adsorbent of the water from the bed. And the water from the bed is flowed directly to the condenser, where we change the steam is changed of the water change the condition from the steam to the liquid, and the water in the liquid form is flow out from the condenser. The world largest absorption destination plant uses absorption chillers manufactured in Poland. The Poland, the cooling capacity is about 1 megawatt and production is about 100 tons per day. This kind of installation is installed in the solar village in the Kakst. Absorption chillers with desalination function have some characteristics such as coefficient of the performance. For this kind of the technology is low, below that 0.65, is strong, depends on the many design and operation parameters. Specific cooling power is below that 300 watt per kilogram, and lowest CP and COP affect the dimensions and the weight of the installations. AGH in the cooperative with the CACST and the New Energy Transfer Company is conducted research on the method of increasing efficiency of the absorption chillers, such as increasing heat transfer, increasing the heat exchanger between the exchangers, they find the new materials with higher thermal conductivity, increasing of the number of the absorption of the bed, application of the artificial intelligence, use steam for the regeneration chiller, and application of the internal heat regeneration. In AGH is installed the absorption chiller with assimilation function designed by new energy transfer. In this figure is shown the main components of our devices: absorbent bed, evaporator, condenser, distillation tank, and the aerator tank. The main theme of this kind of the technology is shown in the figure. There is kind of the absorption chiller with distillation function, have 3 bed, evaporator, and condenser, and can operating in the mode of the distillation, in the mode of the chilled water production, and in mode of the distillation and chilled water production. The main parameter of this kind of installation shows in the table. The cooling capacity is about 1.5 kilowatts, and the daily distillation production is about 40 kilograms. The figure shows the main components of the absorption chiller. On absorption chiller with distillation function, research from the AGH can testing the applicable of the hot water temperature for the specific daily water production, COP, and specific cooling power, and the testing how the cold water temperature influence on the desorption of the bed, how the different type of the time of the absorption desorption influence of the COP and all effective of the system, and we can analyze how the different concentration of the saline water influence of the total efficiency of the system. One of the research conducted on the absorption chiller with distillation function is optimized of the absorption of absorption chiller with distillation function, where analyzed influence of the different heating water temperature in the range of the 55 to 85 to 2 degree on the COP, CP, and specific daily water production. And the study was designed to analyze the effect of the different cycle time on the performance of the absorption chiller. We use a 6 times of the cycle absorption desorption from the 100 to the 900 seconds. The figures show the influence of that on the temperature of the hot water on the COP of the absorption chiller, and from the 55 to the 85 to 2 degree. When we're increasing the temperature, the COP of the absorption chiller is increasing from the level about 0.2 to the 0.6. Next figure that show the influence of the heating water temperature of the SCP, specific cooling power, and increasing of the temperature. We observe increasing of the value from the about 25 watt per kilogram to the temperature about 85 to 2 degree is around 160 watt per kilograms. Next figure that show the influence of the hot water on the average pressure inside the evaporator and the average temperature. For the highest temperature, 85 to 2 degree of the hot water, and the pressure is below 0. kilopascals, and temperature is about below the 12 to 2 degree. The next figure to show the influence of the heating water temperature on the average of the specific daily water production, increasing of the temperature of the hot water for the regeneration of the bed, influence on the production of the condensate from the level from the 0. kilogram per hour for the temperature 85 to 2 degree to about 1.67. Next step of tests is checking how the different type of the process of absorption desorption influence on of the total efficiency of the installation and specific daily water production and specific cooling power and COP. In this figure show the different type, different temperature, and the change of the temperature during the different time of the absorption and desorption from the 100 to the 900 seconds. The next figure then show the pressure change in the beds, evaporator and condenser for specific cycle times. And in this figure, this shows that the time of the cycle is below 100 seconds is not acceptable for this kind of the devices because we don't have a stability parameters for the operating of this kind of the device. And the time up to 500 seconds, such as 600 and the 900 seconds, have the huge influence on the stability working of the installation, because in this higher time of the desorption of the process, the desorption process is observing increasing temperature of the evaporator and the condenser, and this kind of the difference for condenser and evaporator have a significant influence on the total efficiency production of the distillate during the desalination of the process. This figure shows the change electrical conductivity of the condensate from the beginning of the test. The node of the test, the bring have the conductivity about 46 millisiemens per centimeter, and when we end of the test, we have the conductivity about 56 millisiemens per centimeter. Distillate produced during the whole of the process have the same level, 0.07 microsiemens per centimeter. In this figure, they show the comparison of the change in the COP values for all cycles time tested, and that we observe for the 900 seconds have the higher the COP, for the 100 seconds is the lowest. In this figure show the compare of the 900 seconds with the 100 seconds, and for the 100 seconds we have the COP in the level about 0.4. For 900 seconds is up to maximum to the 0.8. In this figure, they show the specific cooling power with the COP, and what is observed with the increasing of the time of the absorption, we observe increasing of the COP from the level 0.34 for the 100 seconds, for COP about 0.68, but specific cooling power is from the 120 to 100 for 100 seconds, and maximum have about 156 for the 500 seconds. And next figure shows the influence of the cycle time on the specific daily water production, and for the 100 seconds about 1.20 to 1.22 kilogram per hour. For the 500 seconds about 1.67 for the 600 and 900 seconds is going down to the level maximum 1.2. The HGH with cooperated with the new energy transfer and the CACS, they prepare the new materials for absorption chiller analysis determine the influence of the additives to silica gel depending on its amount of the process and absorption of water vapor. And the purpose of this kind of the research is to improve the efficiency of the absorption process within the bed by use of the metallic and non-metallic activities, characterized by the higher thermal diffusion than basic absorption bed materials. In this table, it shows the different type of the materials that additives that is added to the silica gel from the level from the 5% to the 50%. In this kind of the research, we use aluminum, carbon nanotubes, and the copper. All the research is doing in one of the devices. This is the dynamic gravity vapor absorption kinetics, that we can operate it very low pressure, high vacuum, and in the range of the temperature from the 5 Celsius degree to the almost 85 Celsius degree. In this figure, we show the absorption kinetics graph for all of the temperature and all the additives added to the silica gel. And this is one of the example of the results of the analysis that can show that silica gel with the 50% of the aluminium have the shorter the time of the increasing of the mass of the absorption. And the research from the AGH and the CAX and the new energy transfer do some modeling of the absorption chillers, and they use the ANSYS software. This kind of the program can be used for the optimization of the combustion chamber, and we can optimize of the evaporator condenser for increasing of the efficiency and the daily water production of the absorption chiller with desalination function. In this figure show the distribution of the temperature and the pressure distributed in the stationary of the bed. And this figure show the flow of the vapor inside the adsorbent beds during the process of the adsorptions. And the research from AGH and the new energy transfer do some research conducted to find the new product, the new adsorption chillers operating in the moving bed. This kind of the adsorption have the highest efficiency and the low mass if you compare with the stationary of the bed. And the conclusion: the adsorption chillers with desalination function are alternative to the older devices used to desalinate water. Adsorption chillers give the possibility of using energy from the renewable sources, and of course the lowest value of the CCP and the COP are obtained for the cycle that lasts for the 100 seconds and the respective 150 watt per kilogram, and the 0.37 and SDP to 0.88 kilogram. The highest SCP value of 150 pounds was obtained for the 500 seconds. Future research needed to improve the efficiency of the desalination of the adsorption chiller. Thank you very much for your attention.
Result with the actual data that we get it from the local market here, or local conditions, I mean, and looking forward to apply this in the field. Our last presentation is from Dr. Raed Rouais. He's been a postdoc at KAUST, which is King Abdullah University for Science and Technology, and he's also assistant professor at Al Jouf University at the College of Engineering. Dr. Raed is specialized in water desalination, and also he has interestingly has a bachelor degree in civil engineering at 2012. Dr. Raed, it's yours, please go ahead.
بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين. أيها الحضور، السلام عليكم ورحمة الله وبركاته. يسعدني في هذه الندوة المختصة بتحلية المياه بالطاقات المتجددة أن أقدم إحدى التقنيات لتحلية المياه وتعتبر واعدة، ألا وهي والتي تدعى Direct Contact Spray Evaporation and Condensation. لا يخفانا جميعا بأن التقنيات المستخدمة حاليا في محطات التحلية سواء بالممبرين أو بالثيرمال، إما الRO, MSF أو MED، تواجه بعض التحديات وبعض المشاكل التي منها الهاي كابيتال كوست والهاي اوبريشن كوست. ايضا من المشاكل انها لها عرضه الى البايوفاولينج والسكيلينج والكروجن. ايضا الهاي كيميكال يوز، والسبب الذي ادى الى هذه المشاكل وتكونها هو وجود الانترفيس او الهارد انترفيس ماتيريال التي يقصد بها الار او الممبرين ان الار او والتيوبس ان الام اس اف والام اي دي. من هذه المشاكل التي وجدت في التقنيات المستخدمه حاليا انطلقت فكره المشروع او انطلقت فكره مشروع تقنيه Direct Contact Separate of Operation and Condensation حيث تمتاز هذه التقنية Direct Contact Separate of Operation and Condensation بالعمل تحت الفاكيوم بريشر under vacuum pressure، وهي عبارة عن سهلة التصميم، غنية عن أو مستغنية عن الهارد interfaces such as tubes or membrane. في حالة الاستغناء عن التيوبز والممبرين سوف تقل الكابيتال كوست، تكاليف الكابيتال كوست الكابكس، أيضا سوف تقل الأوبريشن كوست، وذلك لعدم وجود الكيميكالز ولا وجود للفاولينج، إضافة إذن لا وجود للسكيلينج والكروجن. واللاعب الدور الأساسي في هذه التقنية هو الإكسيس انثالبي ما بين الفيد ووتر وما بين التشامبر نفسه، لأن التشامبرز تعمل، لأن السيستم بالكامل يعمل تحت الضغط under vacuum pressure. إضافة إلى ميزة أن هذه التقنية إمكانية العمل أو استخدام الفيد ووتر تمبريشر أقل من 70 درجة مئوية بعكس ما هو موجود في الام اي دي والام اس اف. أيضا إمكانية العمل أو التعامل مع الهاي سالينتي، الماء العالي التركيز الملوحة حتى تصل 150,000 بي بي ام، بمعنى في المستقبل قد تستخدم كهايبرد سيستم مع نظام الار او في محطات التحلية. إضافة أن في حال العمل على المالتي ستيت بالنسبة للدايركت كونتاكت سيبريت اوف اوبريشن سيصل معنا الانتر هيت ريكفري إلى 70%. طريقة عمل هذه التقنية هي عبارة عن تو تشامبر متصلين مع بعض، إيفوبريتر كونتنسر. فنلاحظ أن في الإيفوبريتر اللي موجود على اليسار يكون الفيد ووتر الداخل إليه بدرجة حرارة تصل تقريبا فور اكزامبل 65 أو 60%، ودرجة الحرارة الموجودة في الإيفوبريتر سيتويشن داخلي تكون أقل من درجة الحرارة الموجودة بالنسبة للفيد ووتر، فيحصل لها فلاشينج مما حصل كهو الدروبلت اللي باللون البرتقالي، وتتحول الفلاشينج تتحول إلى استعادة الكولبينيوم، فتتحول من الحالة السائلة إلى البخار الماء فينتقل إلى الكوندنسر سايد. فعندما يذهب الكوندنسر سايد نتيجة لفرق درجة الحرارة والضغط فتكون درجة الحرارة الفيد ووتر بالنسبة للكوندنسر جدا أبرد من الفيد ووتر بالإيفوبريتر، فالدروبلت أو الووتر فيبر دروبلت المنتقلة من الإيفوبريتر كوندنسر يحصل لها تكثف، يحصل لها كوندنس في الدروبلت بالكوندنسر مما يزيد الإنتاجية. كما هو معلوم ان الووتر فيبر الدايمتر له تقريبا 10 أس ماينس 10 يعني 10 ماينس 10 10 to the power minus 10. ولكن هذه التقنية كانت تقريبا بدأوا فيها من عام 1981 وكان من العوائق أو من المشاكل التي واجهوها أن البرودكشن جدا قليل وذلك لوجود دلتا تي أو فرق درجة الحرارة ما بين الفيد والبرايم كانت جدا عالية. فبدأت فكرة المشروع بأن يقلل درجة الحرارة وذلك بزيادة السيرفيس اريا للتروبلت. فباستخدام أحد الديفايس أو إحدى التقنيات التي تسمى المايكرو بابل كما هو موضح لنا، وهو تعمل على ووتر. بالنسبة للووتر الذي يدخل مع الليكويد انتري تانجنشن البريشر يكون أقل من 2 بار. أما بالنسبة للعمود الآخر الذي يسمى ووتر فيبر اللي ووتر فيبر انتري فيسبب كما هو مسبب كما نرى الآن بالفيديو، نرى أن الووتر الداخل يسبب روتيشن تانجنشن روتيشن، لكن الووتر فيبر حصل له سكن مما عند الروتيشن للمويه وخروجها مع فوهة هذا النوزل يسبب تصادم مع الووتر الموجود في حالة الركود في الخزان الذي يتم فيه توليد المايكرو بابل، مما يسبب الشير فورسي كما هو واضح لنا بالفيديو اللي تحت. الفيو بالنسبه للفرونت فيو والسايد فيو نلاحظ انه باللون الاسود حتى بين الكاميرا كانت الكاميرا بالشكل المعاكس، فحصل لها الشير فورس مما ادى الى توليد مايكرو او نانو بابل انسايد دروبلت. فكانت تكون طارها ما بين 10 الى 25 مايكرومتر، ولابد ان تكون درجه الووتر فيبر الداخله الى المايكرو بابل ديفايس تكون اقل من درجه الليكويد نفسه حتى لا يحصل لها كلابس. اما بالنسبه لليسار نرى ان هذه التجربه المقامه التي اجريت عليها هذه التقنيه، نوجد ان بالنسبه للصوره جنبي هذا يوضح هذا ديستيليت تانك. المستخدمه هنا تقريبا النوزل التي يستخدم بها الرش داخل تو تشامبر الكوندنسر والإيفوبريت. كانت النتائج حصلت الى ان كان الفيد تمبريتشر المستخدم في الإيفوبريتر متغير فرضا من 38 الى 41 الى 60 درجه مئويه، واما اللي مشكل بها باللون الاحمر هو تقريبا الساتوريشن بريشر مقاس بالكيلو باسكال. كانت النتائج مقارنه ما بين بالاستخدام بالمايكرو بابل كما هو في العمود الاخير وبدون استخدام المايكرو بابل، فكانت النتائج انه حصل فيه امبروفمنت بمقدار 30 او 32 الى 34% في البرودكشن عند استخدام المايكرو بابل مع الدايركت. حصل فيه improvement، حصل في برودكشن من between 32 to 34. بالنسبه للسيموليشن يوضح هذه الجراف الاول والجراف الثاني يوضح لك ان التمبريتشر كيف فرق حصل السيموليشن ل 11 ستيتس. فحصل ان نستخدم البرودكشن تقريبا في كل ستيج الاول والثاني الى 90 او الى بالنسبه للستيج الاول في الستيج الثاني، وهكذا كيف نجمعهم مع بعض. ونرى الان ما هي فائده المالتي ستيج. عند استخدام المالتي ستيج يحصل لنا الهيت ريكفري يزداد تقريبا نصل الى 70%. ليش ولماذا؟ لان النظام ككامل، نظام هذه التقنيه يعمل بالاندر فاكيوم. ففرضا عندك في الإيفوبريتر سايد درجه الحراره كلما انتقلنا من ستيج 1 الى ستيج اقل 2 او ستيج 2 تنزل درجه الحراره، بينما يكون بالعكس في الكوندنسر تزداد، لان الكوندنسر يتم تغذيته من الستيج اخر ستيج اللي هو ستيج فرضا من ان، بينما الإيفوبريتر يتم تغذيته من ستيج 1. فعندما تم التغذية يكون الإفوبريتر هنا والكوندنسر 1 والإفوبريتر 1 والكوندنسر 1 تقريبا درجة الحرارة والبريشر بينهم الفرق جدا بسيط، فيكون الخارج أو الديستليت أو البرودكشن الناتج من الكوندنسر 1 تكون درجة فرضا إذا كان درجة الحرارة 72 الداخلة إلى الإفوبريتر 1 تكون الخارج 66.6 فور إكزامبل. فنحتاج فقط لفرق درجة الحرارة تقريبا فقط 4 درجات إلى 5 درجات أو من 3 درجات إلى 4 درجات حتى نصل إلى 72. نلاحظ هنا في الاكستنجر 2 أن الهوت ووتر إنلت يدخل تقريبا بدرجة 75 والخارج فرضا 65، ويكون التبادل الهيت اكستنجر يحصل له فقط لأن السي ووتر الداخل له 30 درجة. السي ووتر من التغذية تقريبا درجة حرارة 30، فيحصل الفرق فقط 3 إلى 4 درجات، يعني من الهيت ريكفري يزداد من نفس الكوندنسر من نفس السيستم، لأن السيستم ككامل يعمل تحت الأندر فاكيوم. ولكن في حقيقة الوضع في هذه التجربة قيمت على سنجل ستيج. عملت هذه التجربة على المالتي ستيج بطريقة اسمها البيس وايز تكنيك، وهي بحكم انك تاخذ درجة الحرارة من الستيج الأول وتدخلها على أساس أن درجة الحرارة الستيج الثاني وهكذا. وحصلت النتائج هذه عمل في اللاب على 6 ستيجز، فكانت النتائج أن البرودكشن تقريبا وصل إلى 1400 لتر بير داي لكل كيوبيك متر. ويوضح لنا أن العمود الأزرق هو الدايركت كونتاكت برودكشن without مايكرو بابل، بينما العمود باللون الأحمر يبين لنا with المايكرو بابل. فنلاحظ أن في الستيج الأول والستيج الثاني والثالث إلى الستيج السادس تقريبا المراحل الستة نلاحظ أن في برودكشن ازداد improvement تقريبا من 30 إلى 34%. أما بالنسبة اللي بالخط المشكل بالمنقط باللون الأورانج، هذا يوضح الفلاشينج، ظاهرة الفلاشينج بين الليكويد دروبلت والفيبر تشامبر تكون اللابد للديكتي أعلى من 3 كلفن أو 3 كلفن، وهذا يعود السبب إلى أمرين. الأمر الأول أن the minimum threshold for flushing between liquid and vapor phase about from 1.5 to 2 Kelvin. أيضا أن درجة الغليان evaporation effect is about 1 Kelvin from salinity of seawater. ولقياس فعالية هذه التقليح نقوم أو نعمل على مقارنتها بالتقنيات الأخرى. نقوم بعمل على البيرفورمانس ريشيو، وهو بمعنى الديستيليشن كم طلعنا برودكشن والهيت او الانرجي انبوت والبرودكشن اللي خرج لنا او طلع اللي حصلنا عليه البرودكشن كم. هذا المعيار لمقياسه مع التقنيات الاخرى. فوجدنا ان باللون الاحمر يبين لك with microbubble واللون الازرق يبين without microbubble. اوجدنا ان في 6 ستيت اوجدنا ان البيرفورمانس ريشيو تقريبا 3.3. نصل وإياكم الى الكونكلوجن، وبامكاننا نقول ان الدايركت كونتاكت هي تعتبر سمبل ديزاين تقدر تعمل على مواجهه التحديات بالنسبه للهاي كابيتال كوست والاوبريشن كوست. هاي اوبريشن كوست بإمكانها تقللها إلى 50%، أقل ب 50% من الار او، وبالنسبة للأوبريشن كوست تكون أقل من 65% بالنسبة مقارنة بالام اي دي. أيضا بإمكان عملها على لا تواجه بعدم وجود الانترفيس هارد انترفيس ماتيريال. إذا لا وجود للفاولينج أو البايو فاولينج، لا وجود للسكيلينج، لا وجود إلى الكوروجن. إلى أيضا من الميزات الأخرى بأن لها قابلية العمل مع الهايبرد سيستم للار او، يعني الار او يكون الريجكت او البرايم للار او السلنتي جدا عالي او الكونسنتريشن تكون عالي، فبامكانيتها تعمل لانها الدايركت كونتاكت سبراي تعمل حتى لا فعليا تعمل اعلى الفيد ووتر، يعمل حتى تقدر لها قابليه العمل على هاي كونسنتريشن اعلى من 150,000 بي بي. شكرا على حسن استماعكم والسلام عليكم ورحمة الله وبركاته.
Thank you, Dr. Raed. Shukran. Thank you, Dr. Raed, for such a presentation and the data. I was really interested in seeing how's the effect of the bubble surface area on the efficiency. As I understand, there's not much of questions from the audience, but I would like to first, I would like to say two comments, then I will ask our speakers if they have any final concluding remarks. Regarding the Al-Khafji plant, which was mentioned in Dr. Faisal presentation, actually Khafji has been working for the last 3 years. I got this information from my colleagues at Saudi, at the Desalination Water Conversion Corporation, SWCC. The Khafji plant has been working for 3 years. It is planned or it's the design capacity 60,000 cubic meters per day. And actually, it is connected to the solar. As you imagine, that the capacity factor of solar is 5 or 20%. It's factor of 5, so 20%. So it takes 20% of energy from the PV plant, and it works at night or when the sun is down. It takes the energy from the grid. And I imagine there is a tremendous amount of information available in the operation and maintenance of such a plant. My other comment is that, as you see here, renewable energy is still a lot of work in the R&D phase or in the labs, but eventually it has to be economical compared to the conventional desalination. And I think economics comes from two factors: from capacity, from making sure that it's a huge capacity, increasing economy of scale, meaning that a plant which produces 60 or 1,000 or 2,000 or 1 million, it has different levelized cost of water production. And the other factor is really that I think which would make renewable energy more economical is the regulation regarding carbon emission. If that is being well regulated, that will give better economics for renewable energy. So I think this is all in the developing phase. I think within the next 5 years, we might have a commercial plant that uses renewable energy in water desalination. So I really thank you again. And if you have any comments or concluding remarks, please feel free to take the mic and let's see what your comment before we conclude this webinar.
Thank you, Dr. Maher. I think we have really enjoyed listening to a colleague, and I would like also to thank the audience for staying up too late to listen to this seminar. And it's an important topic, and especially for the kingdom, as our future will be 90% of our water will be from desalinated water. So I think we need to gear effort to combat this challenge. Thank you.
Thank you. Okay. Well, with that, thank you all. I like to thank the organizers. Again, thank the SWCC for this effort. I'd like to thank my colleagues, Dr. Ahmed and Uthman Najdi from SWCC, for really working behind the scene on this webinar. I think with that, we conclude this webinar, and hopefully we see you again in other occasions as we move forward in applying this renewable energy for water desalination. Thank you all. Thank you.